ranges of trigonometric functions. In this lesson, we're going to learn what numbers the different trig functions can equal. For instance, if I want to find the sine of theta, what numbers does it equal? Or the cosine of theta, or any of the other trig functions. Because the trig functions are fractions, it's important that we understand the order of fractions. So I want us just to review from arithmetic. I've written several fractions here. I've got 0 in the middle, and then I have my positive fractions to the right and my negative fractions to the left. So 0, then positive. Of course, we know that 7 divided by 7, or 7/7 equals the number 1. And we know that negative 7/7 equals the number -1. What I want you to notice is that when the numerator of the fraction is less than the denominator, for instance 2/7 and 4/7, which you remember we call those proper fractions, then the number the fraction equals is a number between 0 and 1. In the case where we're talking about negative fractions, when the numerator is less than the denominator, then these numbers are numbers between -1 and 0. Of course, when the numerator equals the denominator, when we talk about positive fractions, that's the number 1, and negative fractions, that's the number -1. And when the numerator is greater than the denominator, then that number is a number larger than 1. And if the numerator is greater than the denominator and it is a negative fraction, then that number is a number less than -1. It is important that we understand those relationships, and now you'll see why. Okay, I have a rectangular coordinate system here, and I have lots of terminal sides because I want to talk about the relationship in the y's and the r's for different angles. Notice my points, the coordinates of those points will be x, y. I know that the distance from the point x, y to the origin is my r. I know that my r equals x squared plus y squared. And of course we know that r is always positive. Now, what I want us to look at is our sine function, and I'll call my angle theta, and of course I know that the sine of theta is defined to be y divided by r. And what I want us to do is to compare the numerator to the denominator. I'm going to start with theta equals 0, which of course is this angle with the terminal side. Now, what I know for this point is that this distance is r, so the x-coordinate for that point is r, and because it's a point on the x-axis, I know that y is 0. So notice that my numerator is 0, my denominator is r, so of course 0 divided by r is 0. So I know that the sine of 0 is 0, and we have talked about that in other lessons, haven't we? Well, now look what happens if I rotate my terminal side. And notice that in each one of these, that r distance is the same. I did that deliberately. We're going to keep the r's the same, and I want us to look at what happens to the y. Well, obviously, y has gotten larger, hasn't it, as I rotate that terminal side. But how does the y distance compare to the r distance? That y distance, that numerator, is less than that denominator. And even if I rotate my terminal side more, well, my y is getting larger, but it's still less than r. So this numerator is still less than the denominator. And even here, my y got larger, didn't it? But of course I know y is the leg of this right triangle, and the leg's always smaller than the hypotenuse. R's the hypotenuse. So even though y got larger, my y is still less than my r. My numerator is still less than my denominator. And look what happens if I look at the sine of 90. Well, we know what the sine of 90 is, don't we? We know that the sine of 90 is 1, and we know the reason is, at this point, if this distance is r, then I know that my y distance is r, and of course all the x's on the y-axis are 0. So my sine here would be y over r, where y is r, which I know my sine is equal to 1. So at this point, because the numerator equals the denominator, the sine of theta equals 1. But look what happens if I move on over. What about this y? It's less than that r. So once again, this fraction's less than 1. And y is getting even smaller, so this fraction's still less than 1. Y is even smaller. And at this point, let's label this point. We know y is 0 because it's a point on the x-axis, and we know this distance is r, so our x-coordinate would be negative r in that case. But we're concerned about our sine, and of course y is 0 over r, so once again the sine of this angle, which is 180, is 0. Now what happens if we choose a theta in the third quadrant? Let's rotate our terminal side. Well, look at your y. Well, obviously your y is negative, so now this fraction is negative, but how does y compare to r? It's less than r, so this number would be between negative 1 and 0. Same thing here, y is negative, but y is less than r. Same thing here, y is negative, but that y is less than r. Now, of course, we know what happens at 270, don't we? We know that the sine of 270 equals negative 1, and that's because for this point, we know x is 0. This is my r distance, so my y equals negative r. So when I find the sine of 270, y divided by r would be negative r divided by r, which is negative 1. So for 270, our sine is negative 1, but then look what happens if we go further. What about this y? It's negative, but y is less than r, so this would be a negative fraction between negative 1 and 0. What about if we move on here? This y is less than r, and what about here? Y is less than r, and on up to around to 360, where of course we know the sine of 360 gets us back to 0 again. So what about this fraction? We know that the sine of theta can equal to negative 1, it can equal to 1, or it's between negative 1 and 1. And in math we say that by saying negative 1 is less than or equal to the sine of theta is less than or equal to 1. So the sine of theta, the smallest number it can equal is negative 1. The largest number it can equal is 1, and it could equal any number between negative 1 and 1. Now I could go through this same discussion for the cosine of theta comparing the x's to the r's, but you would find the very same relationship. You would find that negative 1 is less than or equal to the cosine of theta, and the cosine of theta is less than or equal to 1. Now the next thing I'd like to discuss would be the reciprocal relationships. I know that my cosecant of theta equals r over y. Well, in every case except at 90 and 270, r was greater than y. So, when the numerator is greater than the denominator, when y is positive, we'll have a positive fraction because we know r is always positive. So this number, when the numerator is greater than the denominator and y is positive, will be greater than 1. And when y is negative, because our r is greater than our y, we know that this number will be less than negative 1. And of course, now what's going to happen at 90 and 270? Well, at 90 and 270, at 90, our y is r, so that's r over r, or 1. So our cosecant of 90 is 1. And what do you think is going to happen at 270? We'll have r over our y is negative r. We get negative 1, don't we? So our cosecant can equal to 1, it can equal to negative 1, but otherwise it is either greater than 1 or less than negative 1. Now here's how we say that. Well, we say it like this. Cosecant theta is less than or equal to negative 1, or cosecant theta is greater than or equal to 1. We have to separate that. It is an or relationship. This is and because a number can be between negative 1 and 1, but a number could not be less than or equal to negative 1 and also be greater than or equal to 1. So we cannot use that compound inequality. We have to use separate inequalities. We could use the same discussion for the secant, and we would find that the secant of theta is less than or equal to negative 1, or the secant of theta is greater than or equal to 1. Well, let's talk about the tangent of theta and the cotangent of theta. Those functions are not restricted like the other four functions. And the reason is because of the relationship in x and y. So let's look at that. We know that the tangent is y divided by x. It is possible that x can be less than y, that x could be equal to y, or that x could be greater than y. Because that x and y can be related in any of these ways, y over x can take on any value. So the tangent of theta equals any real number. And also because the cotangent equals x over y, and because of these relationships, the cotangent of theta equals any real number. Here is a summary of these relationships. Now you need to know the ranges of the trig functions. For any angle theta for which the indicated functions exist, negative 1 is less than or equal to the sine of theta is less than or equal to 1, and negative 1 is less than or equal to the cosine of theta, and the cosine of theta is less than or equal to 1. For your tangent and your cotangent functions, the tangent of theta and the cotangent of theta may equal any number. On your secants and your cosecants, your secant of theta is less than or equal to negative 1, or the secant of theta is greater than or equal to 1, and your cosecant of theta is less than or equal to negative 1, or your cosecant of theta is greater than or equal to 1. These two notes are very important. Notice that sine theta and cosine theta are never never larger than 1 or smaller than negative 1. Also, secant theta and cosecant theta are never between negative 1 and 1. Be sure that you know the ranges of these functions. Know what numbers they can equal and what numbers they do not equal. Now let's look at some typical problems that require us to know these ranges. Our instructions say determine whether each statement is possible or impossible. Tell why or why not. It says the sine of alpha equals negative 1 and 2/1000. Possible or impossible? Impossible. Why? Because negative 1 and 2/1000 is less than negative 1. So the reason here is the sine of alpha cannot equal a number less than negative 1. Now look at the second one. It says the cosine of theta plus 1 equals 4/10. Well, I think it's probably easier on this, since it's an equation. Let's just isolate the cosine of theta by subtracting 1 from both sides. We get the cosine of theta, 1 minus 1 adds to 0 equals, and on the right side we have 4/10 subtract 1, which gives us a negative 6/10. So the question is, can the cosine of theta equal a negative 6/10? Well, is that a number between negative 1 and 1? Yes, it is. So that is possible. Negative 6/10 is between negative 1 and 1. Now let's look at number 3. Is it possible for the tangent of beta to equal 1/5 and the cotangent of beta to equal 5? Well, there are two things you have to consider here. First of all, for this angle beta, we know that the tangent and the cotangent have to be reciprocals of each other, and they are, so that's possible. Secondly, what values can the tangent and cotangent of beta equal? Well, they can equal any real number. So since 1/5 is real, since 5 is real, and because those are reciprocals, this is possible. The reason 1/5 and 5 are reciprocals and tangent beta and cotangent beta equals any real number. Now let's look at this last problem. It says the sine of omega equals 2 and the cosecant of omega equals 1/2. Now notoriously I will put this type of problem on a test and my students will say, oh, sine, cosecant, they're reciprocals. Oh, 2 and 1/2, they're reciprocals. Possible. Well, yes, the sine of omega and the cosecant of omega have to be reciprocals, and these are reciprocals. But what do we know about the sine of omega? It cannot be a number larger than 1. And what do we know about the cosecant of omega, or of any angle for that matter? It cannot be a number between negative 1 and 1. So this is impossible for two reasons, but I'm just going to state one. Sine omega cannot equal a number greater than 1. As you finish your trig course, you will understand how important it is to know what values your trig functions can equal and what values they cannot equal. You will use this information quite a bit. This completes the lesson on the ranges of the trig functions. Please rewind the tape before you return it to the LRC. Thank you.